So, we have a number of different project management methodologies that we talked about. The first one is in many ways, the obvious one. The classic software development lifecycle model, systems development lifecycle model, also known as the waterfall model. This is the one where you start with your feasibility study, and then you do an analysis, and then you do a design, and then you do an implementation, and then you do your testing, and then you maintain it. So you do a complete feasibility study, and you don't start your analysis until you've done your feasibility in minute, agonizing detail. And then once you've done your feasibility study, then you move on and you do your analysis. And you only do your analysis. And you analyze everything in excruciating detail, and you do a massive document with all the results of your analysis. And then you move on to your design. And when you do your design, you look at the analysis you've done in intricate detail, and then you take that to the next level, and you do a very, very detailed design. And then you try and implement your ridiculously detailed design, and then you test it, and then you maintain it. And in theory, at any point, you're supposed to be able to go back to the previous stage. If you get halfway through your implementation and you realize there's an error in your design, you can stop midway through your implementation and go back to your analysis, which might also mean you need to go back to your or go back to your design, which might mean you then need to go back to your analysis as well, and possibly even go back and question the entire feasibility of the project. The problem is, if you've got a large-scale team, trying to convince the project manager that actually there is a significant problem with your implementation that needs you to go back to the previous stage is quite difficult. Because if you do have to go back a stage, why might that be a problem? Why might the project manager be unwilling to go back a stage? Aside from admitting that they've made a mistake, precisely. If you have to go back a stage, then it's going to mean your project is almost certainly going to be delayed, and it's going to cost you time, it's going to cost you money. So it's very hard to go back a stage if at any point you realize that you've made a mistake earlier on in your specification or your design. You want possibly the logic behind the proper formal implementation of the waterfall model is you don't move on to the next one until you go back. You don't move on to the next one until you finish the previous one. The whole point of the waterfall is that waterfall falls, it doesn't flow up. You're not supposed to go back. Though, in theory, you can go back, but you have to negotiate quite strongly with your project manager. And it might be that you agreed at some point that you can go back, though it wasn't designed, the system wasn't designed for you to go back. So there are a lot of issues with this, but it was the original, the sort of this is perhaps one of the oldest project management methodologies or system development methodologies that exists. And so it's nice and simple, but it does have these inherent flaws. But it does make the project much easier to manage, assuming everything goes according to plan, because you can say what your budget is, you can say what your timescale is, and you can see how close you are to meeting your targets. But as we've already said, it is quite inflexible. It also has another problem. It might be that you're designing and you're building the system, and it might be that your project is supposed to be taking 2 years. It might be that your specification changes. It might be that your customer actually says halfway through, you know what, we're building the system, but this isn't what we need anymore. Our requirements have changed. If that happens, well, there's no mechanism for dealing with that. So this is one end of the extreme. It's great for building systems on time, on budget, very easy to manage, very easy to see progress, and it is the original system development methodology. But it does have these inherent flaws. At the opposite extreme, there is another system which goes by at least 3 separate names. You may well find more. Rapid application development, or the spiral model. Some people also refer to it as prototyping. And the way this works is you do some basic analysis of your problem, then you design a solution, then you implement your solution, then you test it, and then you go back to the customer and you show what it is you've built, and you say, what do you think? Is this any better? And the customer will give you some feedback. So you then analyze the customer's feedback. You do a new design, you do a new implementation, and then you test this second version. So with the spiral model, you go round and round and round. You go through this continuous process of analyzing, designing, implementing, testing, analyzing, designing, implementing, testing. Prototyping is a good way of thinking about it, because you start out by, this is a great way of building websites, for example, or mobile phone apps especially, because you can very quickly knock up something that looks roughly right on a mobile device. So you go to your customer and your customer says, we want an app that does this, and we've got this much money, and we've got, I think, 6 weeks. And you say, okay, so at the end of the first day, you can go back to your customer, you can say, what do you make of that? And they go, wow, that was quick. And it is not quite finished yet. Most of the buttons don't work, but the customer can immediately see progress, and it means that every member of the team can immediately see there's something tangible. There's something that you can discuss, some immediate things that can be used. And then you take it to your customer, and the customer will look at it and say, hey, that's very impressive. You've done that in a day? Wow. Well, except maybe you can change that color and move that button around slightly, and actually we probably don't need that feature. So then you go back and you analyze their feedback and you do a new design, and then you make a second build of it, version 2, and you show that to the customer again and get their feedback again. And they say, yeah, that's much better actually, that's much more like it. And you keep going round it's iterative process, this looping process. The word iteration is probably a good one to use. It's this iterative cyclic process where you go around until either you run out of money, or the customer is happy with the results, or you run out of time. So those are the benefits. You could also argue that those are disadvantages, though, because at any one stage, if the customer says to you, how long is it going to take? You have no idea. It's very difficult to predict how long it's going to take to get it perfect, and how much, therefore, it's going to cost. But it works very well, especially with small teams, where you don't want to create mountains of documentation. You just want to get a product that everyone can see, that everyone's happy with. Agile. What did you find out about agile technologies, or agile methodologies? What do we know about agile so far? Agile is one of those things which is misunderstood. Most people understand the waterfall method because it is so simple. You do that, then do this, then do this, then do this, then end. And even prototyping makes sense. I mean, most people have an idea of a prototype, which is just a sort of an early build, and then you use it to refine it, and then you do a second prototype, third prototype, fourth prototype. Oh, well, the fifth prototype is production ready. Agile is a bit different. Agile is actually not just one methodology. It's a collection of methodologies that sort of sit somewhere between these two extremes. So if on the one hand you've got your waterfall methodology, on the other hand you've got the spiral methodology, you can think of these as two polar extremes, two entirely different ways of tackling the project. Agile methodology sits somewhere in between them. And it's not just one. If someone says what project management methodology you're using and you say agile, then you might be demonstrating your lack of knowledge. Agile is not one methodology. There's a number of different agile methodologies. I'm not going to go into all of them. There's feature-driven programming as one. If you want to know more, then Google it. There's dynamic systems development method, which is different to feature-driven programming. There's Scrum, and there's extreme programming. And these are the two I'm going to go into a little bit more detail about. So these are 4 different agile methodologies, but there are actually many more than this. And the aim of these agile methodologies is to try and capture some of the benefits of the waterfall method, but combine them with some of the lightweight, documentation-free environment of just raw prototyping. So So there's 4, but if you just Google Agile or go to Wikipedia and have a look at the Agile, there's a list of many more. But I think this should help explain it a bit, because I mean, it doesn't help that there's one called Agile Modeling. But Agile is just basically a list of different methodologies. And there are standards. There's an Agile group that tries to maintain a list of what is Agile and what isn't. So let's have a look at Scrum in more detail. The Scrum process starts with what they call a product backlog, but that is effectively just a list of features that's been agreed with the customer. So you have a meeting with the customer and you agree the product backlog, which is just a list of features that the customer wants the program to have. Nothing more, nothing less. That will then lead to the first Scrum meeting, where you will write the sprint backlog. The sprint is a period of time where you are developing code, when you are coding. The Scrum methodology is basically a series of sprints all sort of strung together. Rather than having a project and you set all the goals for the project, and then you spend, so say for example, I don't know, you've got 6 months to work on a project. In the traditional software development lifecycle, you'd spend half of that time planning and preparing and designing and analyzing, and then maybe a month coding and then 2 months testing. The way you'd approach it with Scrum would be you start with a list of features, and if you've got 6 months, then you might have 6 sprints, each sprint lasting 1 month. And before you do a sprint, you start out with a meeting and you agree the purpose of your sprint. Does this make sense? So if you've got a 6-month project, you might agree to have 6 sprints within that. Each sprint has a different purpose. So your first sprint might well be to find out what the requirements are. The second sprint might be to code up those requirements. And the third sprint might be to check whether those requirements were actually what was required or not. No. You don't have to have, you do have to have some deliverable. At the Scrum meeting, you agree what you're going to do during that sprint. What's the outcome of your sprint going to be? But the outcome of your sprints won't be the complete product. It will be maybe one feature in the complete product. In theory, it will be a finished feature, which could be used in the final project, in the final product, but not necessarily. We'll come back to that idea in a minute. So, yes, you start out doing your product. So you start out with your list of features. Then you have your first Scrum meeting, and you agree what you're going to do in your first sprint. Not all your sprints, just your first sprint. And then you do your sprint. Each day you start with a daily Scrum, so you say what targets you're setting yourself for today. You look at your product backlog. You look at what you've agreed, your sprint backlog rather. Start of each day, you look at your sprint backlog. You remind yourself of what you're supposed to be doing and where you're supposed to be heading. And it might well be that your sprint backlog has actually changed. One of the key features of Scrum that isn't formally dealt with in either of the other 2 methodologies, Scrum recognizes that requirements change. You start out building your system. The system that you end up building might be very different to the system you thought you were going to build. It recognizes that as you go along through your project, you might find, well, we were going to build this for the Symbian platform, but no one's using Symbian anymore, so let's change it to run on a different platform, for example. Maybe that's a bit too much of a change, but some of the features that seem crucial at the start of the project might seem not quite so important during the project. You can change your requirements whilst the project is going. With most of the other methodologies, once you've decided your requirements and they've been signed off by the customer, they're fixed until you finish. And you will deliver them, and the customer is contractually obliged to pay you for delivering them. Even if the customer decides at some point, halfway through the project, actually, we don't need this anymore. With Scrum, that's not the case. you're not supposed to. And that's the complete thing. So you start with your product backlog, you decide on what your list of features are. Then you have a Scrum meeting, and then where you write your sprint backlog. So you decide what you're going to do in your first sprint, and then you do your sprint. And you spend no more than 15 minutes each day in a meeting, because another thing that happens during project lifetimes is it's very easy to spend hours and hours in meetings negotiating with the customer unnecessarily. If you set yourself a limit of 15 minutes every day, no more than 15 minutes a day to be spent in meetings, then it means that your coders can actually get on and code, rather than having to sit and paralyzed because the feature that they're writing might or might not be necessary. Well, they can at least get on and write the features that you know are going to be necessary. And at the end of each sprint, you're supposed to end up with a useful product, usually useful code. And that's the same thing, but in sort of diagram form. You start with your product backlog, you agree all your features. Then you do your sprint backlog, you decide what the purpose of your sprint is going to be. And then you go off, and you do your sprint, which can take up to 4 weeks. But each day, you have a mini Scrum meeting. At the start of each day, you have a Scrum, and you decide what you're going to do that day. You remind yourself of what the purpose of being there is. And the big advantage is that you can change your specification during the development process. The customer is not bound with the traditional methodology. Once the customer has signed off on the project proposal, that's what they're going to get, that's what they're going to pay for. And if it takes 5 years and they end up with a product they don't want, it's tough. They've got to have to buy it. Whereas with Scrum, they can change their mind during the project. But again, it's quite difficult to track quality. There's no real way of tracking any quality methodology in there. There's no testing is not fundamentally built into this. So you might produce code at the end of the day. Whether that works with the code that you wrote the previous day depends on how disciplined you are. Yeah. Yes. It does. It's also it is a little bit more detailed than this. This is just sort of an overview, so you have a rough idea of what Scrum is. There's supposed to be a Scrum Master who deals with the customer. The customer and the coders are not supposed to talk directly to each other. The coders are supposed to code. The Scrum Master is supposed to make sure that what the coders produce is what the customer asks. How the customer is involved will depend very much on the Scrum Master. Yeah. It is just a methodology, so the way it's implemented can vary in different places. The project manager, I would guess, would be the Scrum Master, the closest analogy. They're responsible for writing the project backlog and agreeing the sprint backlog and making sure the customer is happy with the code that's produced, sort of being the piggy in the middle. So this is Scrum, which is one of many agile methodologies. Another one is what's known as extreme programming, which is actually very similar to prototyping, where you start out by designing your code, and then you write your code, and then you test it. And listening is what they call evaluation or feedback, but listening is a big part of extreme programming. Listening and coding are the two main things, the big emphasis on extreme programming. But it is very similar to the spiral model. Designing is in there, but it's the big emphasis is supposed to be on coding. And yeah, actually prioritised in one article I read. Coding was number one, listening was number two, testing was number three, and designing was a sort of afterthought. The main emphasis is on actually just doing the programming. And if something is going to help you write better code, then you do it. But if it doesn't help you write better code, then you don't bother with it. So at first glance, I suppose it does look a lot like a spiral model. But whereas a spiral model, you're supposed to sort of spend equal amounts of time on each of the different phases. In extreme programming, the big emphasis is on coding. So those are some agile methodologies. There are many, many more. I wouldn't suggest going into all of them, but pick one or two. Scrum is perhaps the most popular. Um, Dynamic systems development method is specifically mentioned on the spec, so that might be a good thing to do a bit of research into as well, as is feature-driven programming and extreme programming. But yeah, Scrum is very popular. And then there's ITIL. Does anyone remember what it stands for? No, not anymore. No, you're right. Information Technology Infrastructure Library is what it stands for. And it's more for managing lots of small projects in the running of an IT department. So whereas the other three methodologies that we've looked at are for aimed at just managing one big project, ITIL is for managing lots of small projects that need to be done in the day-to-day running of an IT department. It's a structure for managing an IT department. And this is a summary, and there are many words on it, and there's an enormous PDF which I think I've uploaded. If I haven't, I will. It'll be on Moodle. And it explains it in excruciating detail, mainly because I think they want to convince you to spend money on going on an ITIL training course. The main theme, though, is about continual improvement. It's almost the spiral model again, but applied to an entire IT department, and as well as just one particular project. So the idea is that you have the way that you currently do things, your service strategy. This is how you've decided how you currently run your IT department, the systems that you currently have, the procedures that you currently have in place, and you listen to your customers. You look at the incidents and the problems you've had, and you design an improved version, an improved way of managing your department. And then you manage your transition into this new way of managing things. And then you run it. You run your operation. But the focus is on continually improving the processes which are in place within your IT department. And this includes managing changes, and it includes solving problems and your approach to solving problems, and deploying updates, and managing your configuration, making changes to your systems as they exist at the moment. Just making constantly changing, reporting, constantly trying to improve what you have in place at the moment. Managing all the small projects that you need to be able to manage in the running of your IT department. So that's what ITIL is all about. and as a result, it sort of sits by itself. So if we have a look at all the methodologies we've got so far, yeah, you can see how they're all different. They look at the problem in completely different ways. Your software development lifecycle model assumes that you've got lots of people, you've got lots of money, you've got lots of time, and your specification is not going to change whilst you're building it. Your spiral model is the opposite extreme. You probably don't have many people involved, um, and you probably don't have much time. There's probably not much money involved, and you can build a few prototypes. For some systems, it might be that you can't build a prototype. I mean, prototyping wouldn't be appropriate for developing an autopilot system for an airplane, for example. You wouldn't want to build a prototype and then test it, and the plane crashes. You go, that didn't work very well. Let's make another one. There are things to consider when you're trying to choose. In that situation, actually, the waterfall model is probably the best approach. An autopilot system, the specification is unlikely to change that much, and you want to make damn sure that you've thoroughly tested it by the time you get to the end. So it's about choosing the most appropriate project management methodology for the project that you're going to tackle. Agile offers a number of shades of grey between the two extremes of prototyping and the waterfall model. So if waterfall is one extreme and prototyping is the other, then Agile offers a number of options in between, which again may be appropriate for some things. I mean, often when you're building an app or when you're building a program, the reason you're building it is because it doesn't currently exist. And if it doesn't currently exist, you may well find that there are some surprises along the way, and you have some more ideas to bolt onto your main project. And ITIL is for managing the ongoing development of an IT department, and all the projects and all the methodologies and the processes and systems that are involved in that. It doesn't really have a particular start date, doesn't have a particular end date, is a crucial thing about ITIL. There is actually no end date, just a constantly improving process. It's managing a series of small projects, a number of small projects that are all part of the big picture. Whereas the waterfall and the prototyping and the agile methods, they have a very, this is one project and you're just going to manage it like this. You might well have other projects as well. You might well have a project manager managing 2 or 3 projects at once, but they don't fit together. Yes, ITIL, if you're going to be running an IT department, there will be lots and lots of small projects happening, but they're all part of the big picture. They're all part of one big system. So ITIL recognizes that, and has systems in place and processes in place for making sure that you can prioritize the right projects, and that in upgrading you don't bring a new system online until the old one. You don't destroy the old system until the new system is ready, sort of thing. Some mechanisms in place for recognizing that each small project is part of the big picture. Finally, closing the project. So you can draw a line under that in your notes if you like. We've looked at the 4 main project management approaches, if you like. We've done ITIL, we've done the waterfall model, we've done the prototyping spiral model. Prince 2 would probably, Prince 2 sort of sits outside these in some way. Prince 2 gives you a framework for producing the methodologies and managing your team. And so you can have your Prince 2 project, you can have a Prince 2 project which is also a waterfall project, or which is also a spiral model project. So Prince 2 is compatible with these 3 at least. I don't think it's not really compatible with ITIL because your Prince2 project has to have an end date, whereas your ITIL management style doesn't. Your ITIL methodology doesn't have an end date. So Prince2 and ITIL are not really compatible. I suppose you can be using Prince2 for one of your minor upgrade projects within ITIL. So maybe ITIL can include Prince2. We talked about that before, but yeah, just trying to help build a model of how these work. Um, yeah, so Prince2 is compatible certainly with these three, and you may well use Prince2 within your ITIL environment. Does that make sense? And there's, like I've said before, there are many, many acronyms and methodologies and all sorts of things. Trying to put them all together is not particularly easy. So, closing the project. Again, draw a line under your notes on those different methodologies. Closing the project is the final stage of any project management methodology. So, one of the first and one of the most important things to look at during this stage, during the final stage of your project, is your acceptance criteria. Part of which will be your critical success factors and your, yeah, I'm getting good with the acronyms now. Learning the jargon. So you look at the acceptance criteria, the critical success factors and the key performance indicators that you set yourself, that you agreed with the customer at the start, and you compare what actually happens with what was planned, with what you'd agreed with the customer. Hopefully, you've met at least your acceptance criteria. Your critical success factors have been incorporated in a way that the customer is happy with. You might have associated some bonus with the key performance indicators. So you compare what you actually delivered with what you said you were going to deliver. It may well be that the customer had other ideas as you were going. So whilst the software development lifecycle model, the waterfall model, doesn't allow for you to have ideas as you go through the project, what you can do is when you reach the end of the project, if there were some features that the customer thought, actually, it would be a really good idea if the project can do this, or it wasn't in the project proposal, you might be able to modify the project proposal if you want to renegotiate with the customer, or you could just wait till the end of the project and put it as a future upgrade. It may well be that you've got a maintenance contract of some kind with the customer, in which case, yeah, a future upgrade, future projects, future things to include, is usually a good idea to add, to make notes and include it in your final project report. All of these should be related to business objectives. So just to close the circle, you've delivered these features, and in your final report you can say, we did deliver these features and we will help the business in this way. And there may well be technical and user documentation. I mean, the user documentation will could just be a straightforward user manual. What kind of things might your technical documentation include? Yes? Good? Yes, possibly. So yeah, maybe some training documentation, possibly backup instructions. Um, yes, yes. So often you might have addressed that when you were doing your risk assessment. It might be that whilst you were thinking about the things that might go wrong, these things were included, and you recognised that it was a risk, and you had plans for reducing that risk, and you had a strategy for coping with that risk should the event occur. So that might well be documented in your right at the start. When it comes to the end, you might also write a lessons log. Prince 2 gives details and structure on how to write a lessons log. So if something happened during the project that was unexpected, then you can write about how you dealt with it. And when you then do future projects, you may well draw on the lessons from the past. So yeah, risk assessment would help before the bad things happen, but then after the bad things happen, you can do a lessons log, which may well form part of your final report. I haven't specifically listed it here, but yes, that's a very good thing to include. Yeah, the technical and user documentation. User documentation is, as you say, things like training manuals, how to use the system. The technical documentation will include things like backup instructions, possibly maybe migration or archive instructions, um, and might even include the source code. It might be that once you've built the system and you leave, they want their own people to be able to maintain it. It might be useful for them to have access to the source code to see specifically how the program works. And yeah, FAQs and all sorts of other good things that would be useful for the user to have. Maybe an installation CDs as well. Put documentation, but documentation pack, including the installation CDs, may well be a good idea. If your project was to, I don't know, if you're an outsourced IT company and your project was to upgrade everyone to Windows 8 with Server 2012, then it would be good to give them the installation CDs that they paid for, as well as maybe customer support numbers and other things. All the details that they need. So if you're not maintaining the system, if you're about to leave, you don't want them calling up in a couple of weeks saying, "What's the password?" I mean, that'd be something else that you need to write down in the technical documentation. If there is an administrator password for the system, you don't want them calling you up to ask for it in a few weeks' time, or something disaster recovery instructions, as well as backup instructions, disaster recovery instructions. So if something bad does happen, they don't call you up and say, "How does our backup work?" They should be able to refer to the manual that you've written, which tells them specifically how to do it. Or you could say, "Well, we can help you with that, but it'll cost you £500 an hour." Ideally, of course, that would all have been agreed at the start as part of the project proposal. What kind of things are they expecting at the end of the project? But then there's also your customer is unlikely to be a technical expert. That's why they called you in the first place. So it's useful to. It can, but then your business won't last very long. You won't get many recommendations. Your reputation won't be particularly good if you. Yeah. So there it is. That's the end. That's the end. Are there any questions on any of this? The different methodologies or how to close a project? The final stage in your project. Great. So the assignment has to be in. Well, next week's our last lesson before the soft deadline. I don't know how close you are to finishing, but I would suggest that we spend at least a significant amount of time in the rest of the session finishing our submission, creating our resources and making them look nice and pretty and incorporating all of this. Doing some more research. Share your resources on the Moodle forum and the Moodle blog.